episode 2 of Cloud Tech 10 for the 20th of March 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. Azure Data Lake Analytics and Azure Data Lake Store have arrived in the North Europe region. This takes the number of regions where these services are available to 3. You can now deploy in the Central US, East US 2 and North Europe regions. The Azure CLI became generally available in February 2017. The documentation has been updated with a number of sample commands and scripts covering scenarios around Windows and Linux virtual machines, web applications, and SQL Server. Let's create a Linux virtual machine using one of the sample scripts. Here's the Create a Virtual Machine script. I'm going to click the Copy button here, then switch to my Linux command line, open my text editor, and paste the script in. Save it, and set the permissions. Now let's run this script. First, we create a resource group where our virtual machine's resources will reside. Next, we execute the command to create the virtual machine, specifying the resource group name, virtual machine name, the operating system type, and that we want to also generate SSH keys. And that's it. Simple. A few moments later, and our virtual machine is ready to use. And cleaning up afterwards is just as easy. We'll just delete the resource group like this, and everything we just created has gone. The most requested feature for Azure DocumentDB was support for aggregates, and that support has now been delivered. DocumentDB now supports count, sum, min, max, and AVG aggregate functions. Here's a sample DocumentDB collection containing data for a retail store. With support for aggregates, I can now issue commands like these. Count will give me a count of all of the items in the collection. This query with min will show me the lowest price from all products for a particular brand. And this similar query with max shows me the highest price. I can use the AVG average function to get an average price, or I can use this query with sum to provide a total of all prices. And DocumentDB got another update with the general availability of the DocumentDB API for MongoDB. This feature allows MongoDB developers to use the SDKs, tools and libraries they're familiar with, but with DocumentDB instead of MongoDB as their database engine. This is a great way for developers to move existing MongoDB-based applications to the cloud to take advantage of the power of DocumentDB and the ease of use of a cloud-hosted managed service. With general availability, some new features have also arrived, namely sharded collections, global databases, read-only keys, and some new portal metrics. Here's RoboMongo, a useful graphical tool for connecting to and viewing the content of MongoDB databases. If you've used this tool, then this will look pretty normal. But if I select one of my MongoDB collections here and view documents, again, nothing unusual until you check at the top here and you can see that the MongoDB server we've connected to is, in fact, a DocumentDB instance. And here in the portal, you can see that DocumentDB instance. The collections you can see here were imported using a MongoDB tool designed for restoring MongoDB databases from backups, but unknown to the tool, it was actually restoring to DocumentDB. And in the quick start here, MongoDB is commonly used in Node.js applications. So here's some sample code to connect to DocumentDB using the standard Node.js MongoDB driver. And here is the MongoDB connection string that you'd use in your code to connect to DocumentDB. The variety of virtual machine types available in Azure grew again this week with the introduction of the L series. These virtual machines are optimized for low latency storage workloads, including NoSQL databases such as MongoDB, Redis, or Cassandra. They're powered by Intel Xeon E5 v3 processors, starting with the standard L4S size with 4 CPU cores, 32GB of memory, and 678GB of temporary disk, and going up to the standard L32S size with 32 CPU cores, 256GB memory, and 5.6TB of temporary disk. The storage for the temporary disks is provided by fast local SSDs. At launch, L-series virtual machines are available in the East US 2, West US, Southeast Asia, Canada Central, Canada East, and Australia East regions. PowerBI Solution Templates now support Azure Analysis Services. The largest size of a PowerBI desktop file that can be published to the PowerBI service is 1GB. So, for larger databases, Azure Analysis Services is a must. Using PowerBI with Azure Analysis Services will also enable more control over how frequently your report data is refreshed and allows for partitioning of tables. The PowerBI Solution Templates provide a quick start experience to get up and running with analytics and visualizations, which you can then customize and extend to suit your requirements. Support for Azure Analysis Services can be found in these PowerBI Solution Templates: Campaign Brand Management for Twitter, System Center Configuration Manager, Sales Management for Dynamics 365, and Sales Management for Salesforce. PowerBI Solution Templates are really simple to set up. Here's a quick walkthrough for the brand and campaign management for Twitter solution. After we've signed in to our Azure account, we're prompted to create a new Azure SQL database instance where Twitter data will be stored. Next, we authenticate with our Twitter account and give permission for Logic Apps to use our account. We provide details of search terms that we want to track. I am going to track mentions of my Twitter account and the Azure hashtag. We will also track tweets sent to or from specific accounts. In this case, my account again and the Azure account. Click Run and the solution template is built. Once it's complete, a report file is ready for us to download and use with Power BI. I'll open it now in Power BI Desktop. And here we are, a ready-made Twitter dashboard giving us insights into our outbound tweets, inbound tweets, hashtag graphs, overview information, sentiment analysis, and our most influential tweets, all up and running in a matter of minutes. The Do Azure Parallel R package has been created to allow users of the R language to take advantage of the Azure cloud, making it easier to scale multiple processes across clusters of tens or hundreds of Azure virtual machines. The package is built on top of Azure Batch, which means you can take advantage of Batch's auto-scaling capabilities. To demonstrate how this works, let's set up a simplified Monte Carlo pricing simulation. I'm going to use the data science virtual machine image from the Azure Marketplace, which is pre-configured with tools for data science modeling and development, including RStudio and Microsoft ROpen. In RStudio, I have a script that simulates 5 million possible outcomes. If I run the script on the data science virtual machine, it will take a little while to complete. So let's do the time warp. And eventually this script completes in 927 seconds, which is around 15.5 minutes. Now let's use Azure Batch to run the same simulation. First, I need to prepare my batch environment, so I'll do this using the Azure CLI. I'll create a resource group, a storage account, and a batch account. Back to RStudio. Here's the same script we used earlier with a few simple changes. We download and install the Azure Batch package, do Azure Parallel. We initialize our Azure Batch environment with a configuration file containing the details of our Azure Batch and Azure storage accounts, the type of virtual machine we want to deploy, minimum and maximum number of virtual machines, and our auto-scaling options. This line at the end will delete our virtual machines when the job is complete, which will help us to reduce costs. Otherwise, the code is exactly the same as before, save for one small change here, where do has changed to Do Parallel. This simple change will now cause the code to run in parallel on Azure Batch instead of on our local machine. When we run the script, we see the creation of the pool of virtual machines in Azure Batch is triggered. If we flip to the Azure portal, we can see the pool of virtual machines is being created. After a few minutes, the virtual machines will be ready. We can see we now have 10 servers with 20 processor cores ready for us to use. Now let's run the Monte Carlo pricing simulation. As before, it would take a short while, so let's do the time warp again. And finished, this time at 179 seconds. That's 3 minutes, a 5-fold performance improvement. Instant file recovery is now available in preview for Linux virtual machines using Azure Backup. You can open application files directly from cloud recovery points without having to restore them. I have a Linux virtual machine here, which is running MongoDB, except it looks like there's a problem. Let's check the error logs. Okay, it seems we're missing a file. Let's take a look, and yes, it looks like that file isn't where it should be. This Linux virtual machine is protected by Azure Backup, so let's go to the Azure portal, and on the blade for this virtual machine, we'll select Backup. Now we'll choose the file recovery option. We'll select the most recent backup as our recovery point, then click the download script button. This generates a script we can run on our Linux server, which will connect to our backup. I've copied the downloaded script to the Linux virtual machine. We run the script, and it connects to the recovery point. The files from our backup are now available here. We can now browse the files that have been backed up and look for our missing MongoDB file. Here's the file we need, so let's copy it to our Linux virtual machine. Okay, the file is now in the right place, so just a quick tweak to the file ownership and we'll restart our MongoDB server. Now when we connect to the server, the connection is successful, we can see our databases and collections and the documents in the database. Finally, we disconnect the recovery point from the virtual machine. This is done in the Azure portal by returning to the file recovery blade and clicking Unmount Disks. All done, we've successfully recovered a missing file without having to restore the entire backup, and our MongoDB database is back up and running. Although this would never have happened if we were using DocumentDB. That's all for Cloud Tech 10 this week. Don't forget, tell your friends, like, share and subscribe, or follow me on Twitter. I'll see you next week. Thank you so much. Cheers for watching. Thanks for watching. If you enjoyed this video, don't forget to like, share, subscribe, and follow me on Twitter for more.